Welcome to paper 2H of the November 2024 Edexcel IGCSE for MA1 papers. Okay, let's crack straight on. Show that question. Make sure you show all the working. Writing these as top heavy fractions. Perfectly fine to show cancellation. Of course cancelled. So 12 over 16 becomes 3 over 4. 35 over 7 becomes 5 over 1. 3 times 5 is 15, 1 times 4 is 4, which is 3 3/4. Question 2, the upper bound 1.45, the lower bound 1.35. Question number 3, SOHCAHTOA, we've got the adjacent, the hypotenuse, so cosine of 43 will be equal to x over 8.6, multiply both sides by 8.6, x is equal to 8.6 cos of 43, which is 6.3 to 1 decimal place. Dividing by 0.17 will take us back to the original amount, which is 2,100. To work out the percentage increase, we'll have 806 minus 650 over 650, times that by 100, and that's a 24% increase. So the probabilities of 1 and 4 are the same, so let's call them both x. And if we add together the probabilities of a discrete random variable, they will sum to 1. And that allows us to construct an equation adding together each of the probabilities, equating them to 1. Collect the like terms, subtract 0.52 from both sides, divide both sides by 2, x is 0.24, and 400 times by 0.24 is 96. So we'd expect the spinner to land on 496 times. Question number 6. So we've got 3 rectangles and 2 triangles. The areas of the rectangles are 10 times 15, 6 times 15, and 8 times 15. And then each of the triangles are half times 6 times 8. There are 2 of those. And plug that all in. You get a surface area of 408 centimeters squared. Okay, the 3 lines. So that's the line y equals 1, that's the line x equals 3, and that's the line x plus y equals 7. It does ask us to label them, so there we go. And then we'll rule out the bits we don't want. That's those. You can test a point if you like, but it leaves you with that region R as the one that's been identified. Question number 8. Well, the 4 bananas with a mean weight of 145 will have a total weight of 580. The 5 bananas with a mean weight of 142 will have a total weight of 710, and the difference between those two is 130. So that's 130 grams for question number 8. Question number 9, standard compound interest, so 20,000 times by 1.035 cubed comes out as 22,174 point something something something. So the nearest euro is 22,174. Question 10, adding together the 3x plus 6, 5x plus 8, and 7x minus 9 together. That's going to equal 320. That's the year 11s. We solve the equation to find the value of x. So collect the like terms. 15x plus 5 will be equal to 320. Subtract 5 from both sides. Divide both sides by 15. We get x equals 21. So we can work out the number of biologists in year 11. 3 times 21 plus 6. Then for the pie chart, we've got 126 360ths of the 300 students, which is a total of 105, and the difference between 105 and the number of students in year 11 is 36, so there are 36 more students. Okay, question number 11. Much easier if you just know the internal angle of a pentagon is 108 and the internal angle of a hexagon is 120. It avoids you making the mistakes that I've made right there in front of you. That should of course be 5 minus 2 lots of 180 over 5 is 108, and 6 minus 2 lots of 180 over 6 is 120. You can tell I wasn't really paying attention there. Anyway, those are the angles around E, the two internal angles, so we can work out the remaining angle that's in our triangle AEF by subtracting the sum of those from 360, so AEF will be 132 degrees. AEF is an isosceles triangle, so I'll subtract 132 and split it between the remaining two angles, gives me 24 degrees. For question 12, we'll get a common denominator of 15, so multiply the top and bottom of the first fraction by 3, multiply the top and bottom of the second fraction by 5, and then carefully carry out the subtraction. We get 1 minus x over 15 equals x. If you've got minus x plus 1, that's fine. Add the x to both sides. 1 equals 16x, so x is 1/16. For question B, we want to see the subject. So the first thing I'm going to do is square both sides, get rid of the square root from the right hand side. Then I'm going to multiply by c minus d, multiply both sides by c minus d, and expand to the left hand side immediately. I'm going to bring the fd squared onto the right hand side and the bc onto the left hand side, basically getting the c's on the same side and the non-c's on the opposite side. That allows me to factorise a c out of the left hand side, so c lots of f squared minus b is equal to a plus f squared d. Divide both sides by f squared minus b, we'll get c equals a f squared d over f squared minus b. Anything equivalent to that is fine. The cumulative frequency table, we've got 4, 19, 36, 50, 56 and 60. And then we can plot those on a graph. So remember to plot these at the end points of each of the class intervals. And then we can join these up. There's my effort at a smooth curve. Dot to dot is fine. If you've done dot to dot, that's not a problem for cumulative frequency because we don't know how distributed the arrangements are within each one of those categories. Anyway, the median's at 30, measure that off as 2.4. Mine, anything between 2.3 and 2.7 is acceptable. For greater than 3.7, measure that off. I got 47, so that's 13 less than 60, but they would accept 12, 13, 14 or 15 for part D. Question 14, so powers of 3. On the left hand side I'm going to carry out the subtraction using the indice rule. On the right hand side I'm going to carry out an addition, and therefore the two powers must be the same. 2n minus 1 must be equal to 4 minus 2n. Bring the n's onto the left, the non-n's onto the right, we get 4n equals 5, n equals 5 over 4, or 1.25, or 1 1/4. Question 15, recurring decimal to fraction. So I'll bring the recurring bit up to the decimal point by multiplying both sides by 10. Multiply both sides by 100 because we've got two recurring decimals. Subtract the 10x from the 1000x will give me 990x, and then doing that with the numerical parts we'll get 756, and of course the recurring bits will cancel. Divide both sides by 990, and that simplifies to 42 over 55, as the question asked us to show. Question 16, the angle AOD is 108. It's double 54. If given a reason, again just learn these, the angle at the centre is twice the angle at the edge is sufficient to score the mark. Just keywords: angle, centre, twice, edge. If you use circumference, obviously that's absolutely fine. Or if you said the angle at the edge is half the angle at the centre, that would be just as good. Alright, so we've got 108 in there. OAD is an isosceles triangle, so we could split what's left from the 108 in half to get each one of those being 36. We've now got all but the angle AOC in the triangle ACD. And so if we add up all the other angles and subtract them from 180, we get 26 as the angle CAO. And then for ABC, opposite angles on the cyclic quadrilateral, we can add together our 28 and 36. Subtract that from 180, because opposite angles on the cyclic quadrilateral sum to 180, and we get 116 for C. Question 17. So let's find the vector H to F. To get from H to F, we can go from H to G and then add G to F. It gives us the vector F to G rather than the vector G to F. So I'm going to reverse that and subtract it, so it's perfectly fine. So we'll get 14, subtract negative 5, 2. And that comes out as 9, 12. That's my vector H to F is 9, 12. The magnitude of a vector, we can use Pythagoras on that, so the square root of 9 squared plus 12 squared, which is 15. The magnitude of H to F is 15 units. Question 18, it gives us a straight line, 2x plus y equals 9. So subtract the 2x on both sides to get it to y equals mx plus c form. We can see the gradient of that line is negative 2. It tells us that L is perpendicular to that. So the gradient of L will be the negative reciprocal of negative 2, which is a half. We're going to put it in the form y equals mx plus c. So we know the gradient is a half and it passes through the point 8, 11. So I can substitute y for 11, m for a half, x for 8 into y equals mx plus c and solve the equation to find c. In this case, c comes out to 7, so the equation of the line is y equals a half x plus 7. Question 19, just learn your transformations. It's the first one is 5 places to the left, so 0, 4. The second one is a stretch scale factor of 3 parallel to the y-axis, which is 5, 12, and the third one is a translation along the vector 0, negative 7, so 5, negative 3. If you learn those, they become so much easier. Question 20, full factorization, and we're looking at that being below the x-axis, so it's going to be in between the two critical values, so negative 2.1 is less than x is less than 1. Leaving it as a fraction is fine. A union B, but then the complement of that. So we've got a 5x and a 3x plus 2. That's the stuff that's not in A union B. We know that sums to 26. We can solve the equation to find that x must be equal to 3. Now we could at this point work out every part of the circle, but I'm just looking at A complement intersects C, stuff not in A but is in C, so that's the 5x and the 2x, so that's 7x. 7 times 3 is 21. 21's my answer. Question 22, we've got nonlinear simultaneous equations. It's already set up a substitution for us with the second equation, so I'm going to substitute y for x plus 2 into the first equation. So x squared plus x plus 2 all squared plus x plus 2 equals 3. Expand out the x plus 2 all squared. X squared plus 4x plus 4. I've left the rest alone. And we have a 3-term quadratic, so I've reduced that to 2x squared plus 5x plus 3 equals 0. Factorize this to 2x plus 3x plus 1. Read off the solutions. X will be negative 3 over 2, or x will be negative 1, and we can plug those into the linear equation from the top to work out that y is a half or y equals 1 for each one of those respectively. These come as pairs, so I'll pop them in boxes. Question 3 is the algebraic simplification. Whenever you're simplifying things like this, the key to doing it is to factorize as much as you possibly can, and keep factorizing. Don't stop factorizing. You can start cancelling earlier than I have if you wanted to. If you're confident doing that, that's okay. I've factorized everything I could see once. The difference of two squares. In the first one, I flipped the second fraction and factorized the top and the bottom. I've then gone on and factorized the first fraction's numerator again. So 4x plus 6 is the same as 2 lots of 2x plus 3. And 4x minus 6 is the same as 2 lots of 2x minus 3. Now, everything else I've left untouched. And once we've got it all out there, fully factorised, when you're multiplying two fractions together, you can, of course, cancel anything at the top with anything at the bottom across either fraction. And I've left the minus 7 plus 8x at the end. Alright, now's the fun bit. So x plus 2's cancel, 2x plus 3's cancel, x minus 7's cancel, and that leaves me with a 2 times a 2 at the top, which is 4. We've still got a 2x minus 3. The denominator is reduced to 1 times 1, so that's all gone. And then subtract the 7 plus 8x. Just be careful with the 7 plus 8x, we're subtracting all of it, so I'm just going to rewrite that again without the brackets, and the 8x's cancel, leaving us with negative 19. It's quite satisfying when that happens. Question 24. So diagram definitely helps with this one. So we've got A and B, there's due north coming out of A. We know that's an angle of 67, because it's on a bearing of 067. Then B to C is just there. Let's have a due north of B. And we know the angle there is 129. And due north at C. And there's my line A to C. Now we want to know the bearing of A from C. So I'm going to work out that angle theta that I've labelled there, and then we'll use that to work out what the bearing is towards the end. Then other angles that will be useful, if I drop a line going down from B, we get 51 degrees from the 129, and then 67 degrees is alternate to the angle at A. That length is 8.4 from A to B, and B to C is 9.2. Incidentally, that angle there is going to be 51. It's alternate to the 51 just on the point B there. That will be useful later on. Okay, so finding A to C, we have enough information to use the cosine rule. We can add together the 67 and the 51 to get 118 degrees as that angle. So B squared plus C squared minus 2BC cos A, square root that to find AC, and AC comes out as 15.09 meters, that will be. And then I'm going to use the sine rule to find the angle theta. So sine theta over 8.4 will be sine 118 over the length we've just found. So that angle theta will be multiply both sides by 8.4 and apply inverse sine to both sides. So inverse sine of 8.4 sine 118 over my 15.09. Plug that into your calculator and you get theta to be 29.4. Now we want to know the bearing of A from C, so we need the angle measured clockwise from north. Well, we now know what theta is. We know there's a 51 there, so if we subtract our theta added to 51 from 360, it gives me the bearing. The question wants it as to the nearest degree. Well, that's 280 degrees. That's the bearing, 280. Question 25. On reflection, I actually think there's probably an easier way to or more elegant way of cracking this question open than I've done here. But this way works. I think I possibly could have constructed a line from O to A and then just dealt with a right angled triangle to find the length from A to this point D that I've constructed. Essentially we're finding A to D. If we get A to D, everything else will open up. I think so what I've done is I've connected up these points D and E, and therefore ADE is an equilateral triangle as well. So I've found D to E using the cosine rule. We've got a 120-degree angle, and then we've got X and X. However, if I'd have drawn O to A, I think I could have found A to D just using a bit of simple SOHCAHTOA rather than the slightly more advanced cosine rule. There we go. Here's me using the cosine rule anyway. Cos of 120 is -1/2, and so that all simplifies nicely to 2x squared plus x squared, which is 3x squared, and therefore we can square root that to get root 3, lots of x. The x is not under the square root. So a to d is root 3x, a to e is root 3x. So the whole side length of a triangle will be 2 lots of that, of the larger triangle. It's going to be 2 root 3 lots of x. So using a half AB sine C to find the area of the triangle ABC, we've got a half, the side length 2 root 3x, the other side length 2 root 3x, times by sine of 60, which is the angle between them. And then if we subtract the area of the circle, that will give me the shaded area. It simplifies nicely to 3 root 3 lots of x squared, subtract pi lots of x squared. I have factorised out the x squared from that, so we'll get 3 root 3 subtract pi lots of x squared, and therefore n, well, what the question asks us to find, n must be equal to 3 root 3 minus pi. Plug that into your calculator, write it to 3 significant figures. It is 2.05. Well done if you got that one. All right, bye.